the term presentation for ISM. And our topics is basically robotic process automation for EV charging station management software, specifically to the electric vehicles. And along with me, I welcome Pragya, Samiksha, and Pravesh also to have a quick discussion around this topic. So let's move on and we'll first discuss the problem in the existing landscape of the EV stations, basically. So as we all know that due to increase in the demand, basically day by day on the electric vehicles, there is insufficient utilization of the charging station, whatever we have, and which also lead to a huge wait time and for basically the customers who are using the EV. Lack of interoperability between different vendors and their charging station is also a prime concern here. Uh, Third point would be the limited availability of these stations in different locations. Difficulty in managing these stations remotely is also a major concern. Inadequate infrastructure for fast charging, discouraging long distance travel with EVs, that is also growing concern nowadays. Challenges in integrating renewable energy sources with charging station network to promote sustainability, security vulnerabilities in the charging station network, insufficient standardization in billing and payment system across the charging station. That is also a challenge because it creates confusion and inconvenience to the end user. Limited accessibility and usability of individuals with disabilities, potentially including them from EV ownership and usage, is also a major concern and growing nowadays. With this, I will hand over to Pragya to discuss the feature of this software solution. Pragya, over to you.
Thank you, Alok sir. Okay, so coming to the features of EV charging station management software, there are many software typically ranges that offers operate and manage charging stations. Some of the common features I would like to demonstrate here, like user authentication and access, which allows secure login for users and administrations with role-based access control. Reservation systems, which allow users to reserve charging slots in advance. Then coming to energy management, which optimization of energy usage, load balancing, and demand response capabilities to minimize cost and also grid impact. Then coming to firmware updates, which allows users to remote deployment of firmware updates for the charging stations to ensure they are up to date with the latest features and security patches. Then scalability and customizations, which allows users to scale the software to accommodate and growing numbers of charging stations and customizations options to meet specific business needs or regulatory requirements. Okay, so now
Okay.
coming to the next slides, I'd like to hand over to Pravesh sir.
Thank you, Pragya, and thank you, Alo. So basically, if we understand the problem, there is a EV user who own a EV car, right? And then there is a charge station which need to dispense the energy to the car to charge the battery of the car, right? So between these communication, the car and the charger, there must be a communication mechanism. That mechanism is getting executed by a protocol that is known as OCPP, Open Charge Point Protocol. So using this protocol, which is defined by the OCA, Open Charge Alliance, uh, basically we as a software company, we are building a software for this whole ecosystem to manage the charge stations to car charging for the end user. How it happens is explained in this whole architecture diagram. There is a mobile app which allow to give an instruction to OCPP whenever user go to the charge station and they simply open up the mobile app and they simply start charging through this mobile app, this instruction goes to the remote software, which is CSMS, Charge Station Management System. This check the user authentication, like who is login, what is his RFID, which car he have, which port type he is using. From those remote instruction, it's sent to the backend service center, like authenticate it and confirm is everything is relevant and authentic. Once that authenticated, it goes to the cloud software, which confirm yes, he is authentic user, and now find out the operators who is managing this software and what is the energy rate applied on this charger, and what the session is allowed to execute the charger, what is the power capacity allowed by the charger or the operator. An operator confirms all these instructions and return back to the cloud service. And once the cloud service is confirmed, like yes, everything is under the defined standard, and then the charging gets started. So this whole ecosystem, from the instruction from the mobile app to confirmation from the authenticator, and then confirmation from the operator, and then energy dispense get start from the charger to car. This whole system is designed to manage the this charging ecosystem, and this software is known as charge station management system. The feature wise, our Pragya already explained. Can you move to the next slide? So when we see the complete landscape of this software, we see there on the top of this diagram, these are the major actors. The platform admin is whoever is building the software or managing the software, or the managing the complete ecosystem of charging. They are the platform admin. CPO admin is someone who is managing the charging networks. Let's say I have 10 charge stations and I'm managing through a software. So I am a CPO. Charge point operator is a CPO. And then enterprise admin is someone, for example, let's say Indian Oil has distributed his franchisees to the different part of the country, like state wise, then city wise. So when I am just allowing a franchisee to someone, that uh, that's a kind of B2B deal. So whoever is seeking the franchisee is the enterprise. So those people who is managing the specific station, they are enterprise admin. The operator is a technical team who is ensuring that all the chargers are up and running all the time. EV driver who is owning the car and going to the charge, and the support user is someone who is helping if charger is down, or something is not working correctly. Ground repair staff is someone who is managing the hardware. So these are the top actors to complete to make sure to run the ecosystem smoothly. Value added services is something like either any of these actors would require a sort of dashboard where they can understand what they need to perform as in corrective action, what they need to perform as in preventive action, or what they need to look as in like strategic point of view. Like for the CPO admin or platform admin, they need to understand how many sessions are getting executed, how much energy is getting consumed, and what sort of revenue they are earning, or so, right? And then if I see the if we talk about the complete operation ecosystem, these are the major head points which required to for a robust software. So like alerts should be there whenever charger is overheat. Charger should produce some sort of alert. Notification is something like charging is completed or charging is getting started. This will be your invoice or all that. Fault summary is something like these many charger. So these are the major sort of heads for the to build a complete or end-to-end robust software. And then the major point, which is the topic of this whole presentation, is remote or automation in this whole ecosystem. That is remote monitoring. So when we talk about the automation, this whole ecosystem can be automated through this remote monitoring. So like I said, this OCPP protocol have that capability which can read your predefined conditions and respond accordingly. Let's say you have confirmed like whenever charger temperature goes this much, just simply shut down or reboot it. The remote command will execute basis on this predefined conditions, and charger will act accordingly. Load management is something I mean, we can do automate here also. That how we can do it is, let's say you have a charger, and charger have three sort of dispenser port for the energy, and one is for heavy vehicles, one is for light vehicle, and let's say one is for two wheeler. So if one port is engaged, all the energy goes to that one vehicle. If all three are engaged, the energy gets distributed basis on the ampere capacity of each vehicle. That is the load management software or hardware can do automatically. Here also we can I mean, we can simply implement this automation to manage this ecosystem in real time. Integration layer is something is required for a software automatically to submit the lead or any sort of prospect to a CRM where a CPO can take follow up or something. Then ticketing system. Ticketing system is something. Let's say uh, I have paid, but payment did not get processed. I am as a EV driver. Then I need to raise a ticket. That is the ticketing system we have planned to have in the software. AI is something. AI is basically, as of now, it is more in demand in this whole ecosystem. For the predictive analytics. Let's say since this ecosystem, this EV ecosystem is evolving itself. So what are the routes where I should put the I should start new charge station? What are the charge station where I should put the heavy duty chargers? What are the charge station where I need to put the low duty chargers? For those, these AI always help. Basis on the charging behavior, the travel behavior of the EV owners, the AI helps and suggests you to do the accordingly. So this is again the next level of automation we can incorporate in any CSMS. Can you move to the next slide? So the most and critical item here is the pricing automation. When we talk about the automation, this the most critical or main entity of this whole ecosystem is the price. Price for CPO, price for EV user, price for anyone whoever is the part of this ecosystem, right? So as a CPO admin or as a charge point net operator, I can define the dynamic pricing for the surge hours through the automation. For example, over the weekend, the destination charges inside the mall or parking area of the mall gets huge demand of the charging. By by those days and by those hours, price will automatically surge or increase by maybe XX percentage, whatever is defined. Similarly, if any charger have less utilization, like in the problem statement, Alok explained very first point, like not less utilization of the charger or the not the optimum utilization of the charger. In that case, the software or automation can decrease the pricing to attract the EV user for those hours or those destination to execute the charging sessions. So this is the whole diagram which explain like you can create slot day of the week and you can put the duration there and you can put the transaction fees. Let's say I am putting a charging station in a posh area of any city, right? Where like let's say elite class people are living around, and if that charger required the high demand in charging session in any day of week or any hours of the day, you can define the slots and you can define the pricing. Automatically, it will increase and decrease. That's another automation we can plan here. Please move on to next slide. So this is the high level architecture. I don't know if this is very much required here, but this is the high level architecture. Charger communicate through the OCPP. OCPP, there are two different versions, 1.6 and 2.0. Can you go back? Yes. So charger always instruct with the communicate through the OCPP protocol, and then that OCPP protocol send the ALB this cloud instruction to ALB, and then those instruction goes to WebSocket. WebSocket is something I think this WebSocket is something provided by the cloud host, and this WebSocket transform the instruction received from the ACPP. Then it says to the cache. If something is already stored in cache, then it's I mean these are the storage where it's authenticate the instructions, like who is asking for the request, who what request type it is, what sort of criteria in the request. Those all gets in this storage system. And then a WebSocket process the data once this is confirmed from the cache to the managed scene in Kafka for the transformation layer. And then OCPP core app send this to the end user through these asset management, user management, reporting, and payment and pricing. These are the major area which categorized in the Kafka whenever we program the software. And then the operational user are the CPOs, and the apps are for the EV owner. They use to find out the nearby charger and start the session. So this is the high level architecture from end to start, how this whole thing works.
Yeah, thanks,
So
Pravesh. I think it's time to look for the future trend, right?
yes, yeah,
And Samiksha, can you please explain a little bit more where the trend is going? And
Sure.
yeah,
Thank you, Pravesh sir, for the detailed explanation regarding the system. Now coming to the future trends. Intelligent automation basically merges RPA with AI tech like NLP and ML, enhancing automation with advanced capabilities in processing natural language and learning. Hyper automation. Hyper automation merges the RPA with process mining and decision management, creating comprehensive automation solutions covering end to end processes with enhanced efficiency and decision making capabilities. RPA as a service. Growing use of cloud based RPA solutions and service offerings for enhanced automation capabilities and scalability. Now, the fourth point would be citizen development. Citizen development basically empowers the business users with low code or no code RPA tools, enabling them to independently create and deploy automation solutions without heavy reliance on IT support. Thank you.
thank you. Yeah, thank you. So, thank you, team, for your time. And now we can end the presentation. Samiksha,
Thank
you
you.
can. Okay, I need to stop recording, right?